Okay. So in a reversible reactions, okay, we use the example of NO₂ and N₂O₄, right? So why do we use this? Number one, this is a reversible reactions. And number two, okay, NO₂ is nitrogen dioxide is a brown gas, and N₂O₄ is a colorless gas. So when it is changing in the chemical components, and you can see the observational color change, right? So at the beginning of the graph that you can see the graph over here, this is a dynamic equilibrium graph, right? But I need to explain a little bit what is meant by dynamic equilibrium. So just look at the beginning. If I am reacting from the left side to the right side, okay? So you just imagine there is a lot of the reactants at the first or at the beginning. Now, NO₂, right? Okay, here is a NO₂. Then I will reverse it. Okay, so at your beginning, you start from N₂O₄, right? N₂O₄. So N₂O₄ have a very, very high concentrations in the beginning over here. Okay. Now, NO₂ haven't formed yet. So the concentration is low or zero. Now, during the reactions, okay, during the reactions. So when during the reaction means they started to have the time taken. During the reactions, N₂O₄ started to change to NO₂. So you will see the concentrations of the N₂O₄ started to decrease because N₂O₄ started to use up. All right. And the NO₂ over here, the concentration start to increase because the NO₂, right, being formed. So you will see here, right, start to increase due to NO₂ being formed. On the top, N₂O₄ being used up. So one being used up, one being formed. So you will see the lines, one go down, one goes up. Okay.
Can.
Now, as time passes, right, some of the N₂O₄, okay, already become lower concentration because they already use up. Okay, so the decreasing of the N₂O₄ will become slower and slower and slower. All right, and the increase of the NO₂ also becomes slower. Now, why they become slower at both sides? Okay, why they become slower? Why not faster? This is because when there is a lot of NO₂ and NO₂ builds up, the reactions will reverse. Initially, you started from here, you will break down and form this one. And when this one become a lot, you see, when a classroom become very crowded, some people start to leaving. So that means N₂O₄, when it started a lot, when it break down, when they form NO₂ a lot, NO₂ started to form back N₂O₄. So you don't see the net, or you don't see there is a lot of N₂O₄ have been used up. Why? Because some of the N₂O₄ is being reacted back, right, reacted back from the NO2, nitrogen dioxide. So the decrease of the N2O4 becomes slower, the increase of the NO2 becomes slower, right? So this is why the graph started to see there's no so steep. That's a curve a little bit, no so steep. And they are going to reach a maximum point at equilibrium. So if you see the line, is flat, is horizontal. And now this is called the concentrations become constant. So this is a sign of equilibrium, right? The concentrations become constant. But very important, the reaction has not stopped. Don't say, oh, equilibrium's reach here and the reaction stops. No. What does it mean by the equilibrium is, the equilibrium means you go into the classroom and you leave the classroom at the same speed. So that means N2O4 becomes NO2 and NO2 become N2O4 at the same speed. So when they have the same speed, you does not increase net and or you decrease at net point. So we usually say when there is constant concentrations, that means we reach a dynamic equilibrium. I want to highlight the words of the dynamic equilibrium. Dynamic equilibrium means the speed or the rate of forward reactions. You need to write down this because later we have an exercise for this. Equals to rate of backward reactions. Right? So the rate of the forward reactions is the same as the rate of backward reactions. Forward and backward is the same. That is called the dynamic equilibrium, right? So like the students, these are the students or these are the people who go into the classroom and at the same time they leave the classroom at the same speed. So we call this as dynamic equilibrium. So the number of students or the reactants stays the same because the moving still happening. It's not like we stop, we don't stop. The movement is still happening. Okay, just a speed. So this is called the reversible reactions. Okay, later we'll use this. We have the number one, effects on the concentrations. Okay, what is effect in the concentration? So let's say today I have a certain concentrations and I've reacted and I got equilibrium, so on and so forth. Okay, so for example, I take just now we have the 2 NO2. This is a gas, right? And we have the N2O4. This is a gas as well. Okay, so there's a brown gas, NO2, and there's N2O4 is a colorless gas. Okay, now the Chatelier principle says something like this. When my concentration, okay, of one substances change, the shift will oppose the change. This is what they say. So the simple rule, as you need to remember, is if I add something, I can add here, I can add here, it depends lah. The equilibrium will shift and to reduce the effect. That is number one, if I add something. If I remove something, take this away, the equilibrium will shift, all right, to remove the effect also. Okay, give you one example. Okay. If I add more NO2, right? I add more NO2. So this NO2 will want to remove the extra effects. So what happens to the equilibrium? The equilibriums will shift to the right. And more, they will shift to the right side. Shift to the right side means there are more N2O4 produced. Right? So what do you see? You will see there's a brown color become less intense. So because we cannot see NO2, we cannot see N2O4, the only things we can see is the color changes. So we can see, oh, the brown color become lesser, become paler because colorless N2O4 for more. Right? So the equilibrium shift to the right to do what? To do use up the NO2. To use up the NO2 and to form more N2O4. So when you disturb the equilibrium, this is what happens. All right. This is what the effect, what the reactions. Okay. So let's say we go to the other way around. All right. If NO2, right, is not added, now I remove some of the NO2 or decrease them. Okay. What kind of effect I will get? If I remove some of NO2 or I decrease some of the NO2, the system would try to replace the NO2 that I removed. So as a result, the equilibrium will shift to the left side. So the whole equilibrium will shift to the left side to do what? To form more NO2 because I removed it, they will react and they want to form more NO2 and the brown color becomes darker. So more brown color, form more brown color and becomes darker so the solutions. So this is so-called the effects of change in the concentrations. Okay. The same thing happens to the N2O4. Okay. If I disturb the N2O4, right? If I increase them, they will try to decrease them. If I decrease them, they will try to increase them. So they will play around in the equilibriums. Okay. They will play around. How do I make this more, right? From here. How do I make this more from here? Okay. So this is the Lee-Chatelier principle on the effects of the concentrations. Okay, later we'll go to gases. Gases are more complicated because there are some of the gases, there's some of the solutions, they will mix around. Okay, now we go and see some of the situations here. Okay, so let's say if I have a reactions, A plus B. Okay, NO2, same, become N2O4. Now my NO2, I have 2 mole of the molecules over here. So you look at the number of the gas molecule. At both sides. At both sides. So here you have 2 mole, and here I consider 1 mole lah. Here you got 2 mole, here you got 1 mole. So my left side, okay, my left side, more gases. Okay, my left side, more gases. So I keep using NO2 and N2O4 as an example lah. Okay, right side have fewer gases. Okay, 2 to 1. Now when my pressure increase, the system will try to reduce the pressure. Okay, so when my pressure increase, my system will try to reduce the pressure. How to reduce the pressure? The answer is they will shift to a fewer gases. Okay, so you look at this. Okay, never mind. I write down. So let's say here A and B. Here got more gas, got 3 more of gases. Here got less, got 2. So when the pressure presses, the pressure increase. Okay, what happened is pressure increase. Okay, they will try to reduce the pressure. So how they reduce the pressure? The equilibrium will shift to a less gases. Okay, will shift to the fewer gas molecule. Okay, so when they shift to the fewer gas molecule, in these cases, NO₂ and to N₂O₄ is to the right side.
Okay.
Okay, so the pressure is applied to the whole system, not only on the left side or only on the right side. This one you must know, okay? Now, what happened if I say, if I got these equations, if I got this equilibrium, okay, I want to decrease the pressure of the system. If I decrease the pressure, my system will like to increase the system back. Okay, because my system is disturbed, so I want to do some changes and of course increase back the pressure. So how to increase the pressure? I will shift to the more numbers of mole. All right, so we say the equilibrium will shift shift to the side have more gases. So which side is the more gases here? So if you look at the numbers of mole, macam is here is go to the 3 mole side. Okay, so is shift to the left side. Okay, so decrease in the pressure will favor the side that have more gases. Means at a fixed pressure. So what is mean by at constant pressure? At constant pressure and also addition to inert gas, right? Add inert gases, add in, and you maintain the pressure. So suppose you increase the pressure, right? But now you maintain the pressure. Okay. So give you an example. When inert gases added to a constant pressure, if I use back the same substances, okay, N2O4. Okay. Now this equilibrium adds a inert gas, right? Okay. To maintain the pressure, if I want to maintain the pressure, what I need to do? I need to decrease, to maintain the pressure, okay, into inert gases that added. The container must expand to keep the pressure become constant. If I want to keep the pressure constant, constant, I need to do something. I need to expand. Expand what? Expand my volume. Okay, expand the container. Okay, if I expand the container, right, the reacting gas become more spread out. All right, the reacting gas become more spread out. So if I expand the container, my partial pressure of NO2 or N2O4, okay, or both of them will decrease. Will decrease. The pressure is decreased. So according to Chatelier principle, if the pressure increase, if the pressure decrease, you will shift to the side to increase back the pressure. So it will shift to the left side to increase back the pressure. So I give you a more simple analogy lah in this one. Okay, so more simple analogy is something like in a room. Okay, in a single room, there's a 3 student, 2 student lah. Okay, not enough. Then the teacher say, the room must not be more crowded. The room must not be more crowded. Now suddenly I have some visitor coming in. Visitor coming in. The visitor like inert gases. They don't join your class, they don't join activity, okay? But to keep the room from being crowded, I need to change my room space into a bigger space to accommodate this visitor. Okay, so my room become bigger, right? So that means, okay, this is like the inert gas. So my room become bigger, and now the original students are more further apart, and they stands, they are more spread out. So by adding inert gases, I keep my container expand. I keep my students more, spread out. I don't increase the student number. So I increase the room to accommodate all of them. So if I want to have maintain the same pressure, what happened? I add more students. So the students stay the same spaces. So this is what happened. They say the system want to make more gas particle to fill in the bigger spaces to maintain, all right, the pressure, to maintain the distance between the student. We go to the change in the temperature by using the Chatelier principle. Okay. So, okay. So in a reactions, it doesn't matter what kind of reactions. There must be a heat absorb. There must be a heat release. So you either is a exothermic or endothermic reaction. Okay, let's say if I put this as an exothermic reactions, okay, that means what? That means it's what do you call? It's reactions that will release the heat one. Exothermic means heat release. Exo means exit. Heat release energy. All right. Now, in any of the reactions, okay, they will have a heat have been absorbed first, then heat will be released. In exothermic, your heat release is more than is absorbed. So when the temperature rise in the system of the equilibrium, okay, I give you one example. So in example of, okay, NO₂ again, right? If NO₂ gases wanted to become N2O4, they will have a heat absorb and they will have a heat release. But in this case, right, heat will release more than absorb. So that means the forward reaction is an exothermic reactions. So exothermic reactions is a forward. Okay. Exothermic is a forward reactions. Okay, that means there's more heaty lah. When you touch them, more heaty. So means what? Means if I have N2O4, change to NO2, this is absorbed heat, not release heat. Okay, this way the reverse reaction, the backward reactions absorb heat. Okay, this is a reverse reaction. Okay, the forward reaction release heat, the reverse reactions absorbs the heat. This is what they mean when it's an exothermic reaction. Okay, if I want to disturb the equilibrium, means what? Means if I increase the temperature in this exothermic reaction and give you more heat, we add more heat. Okay. When the temperature in the systems increases, means I give more heat. The system want to remove the extra heat. Okay, Chatelier principle say I will react it by how? By I will remove the extra heat. So now the equilibrium starts to do what? To absorb the heat. Okay, so the extra heat will be absorbed, will be removed to maintain the temperature. So what they need to do, if your temperature increase, you will go to reverse reaction or shift to the left. Right? They will shift to the left. Okay. N2O4 will turn to NO2 so that more heat will be absorbed or more heat will be removed. Okay, can Okay, so this is applied for exothermic reactions. Now, in endothermic reactions, endothermic, so how should I put endo? Okay lah, I put the same thing, endothermic reaction, which is N2O4 plus heat. That means absorb heat. Endothermic means absorb heat. Okay, plus heat pula, plus heat. Heat means the NO2 gases. Okay. Now, what do we know about this reaction is, if my forward reaction is endo, endo means absorb heat. Okay. My reverse reaction, which is shifting to the right, shifting to the left, is release heat. Okay. Now, there comes a scenario. When temperature increase, what happens to my equilibrium? My equilibrium will decrease the temperature. Okay, so the system will decrease the temperature, right? The system will try to lower down the temperature. Now, as a result, right? As a result of the systems will decrease the temperature, the system will absorb more, which is the excess heat, and they will shift to the right. Right? The systems will shift to the right.